Yeah, this is the fourth lesson in kinematics of a particle. We are focusing for the beginning on motion in a straight line with a constant acceleration. This is the heading which actually helps you get into the mood for problem solving basically. So that's what I'll focus first. And then we'll make it more general using integration, differentiation, all that. But remember, within this itself, just in a small heading like that, motion in a straight line with a constant acceleration, you got the best possible problems in kinematics. So, but in the previous class, we have derived the three equations. What are those equations, children? In a simple way, like in a 10th class level only we did it. We wrote the equations as what, if you remember? V equals U plus AT we did. That's over. And 2 S equals U plus V by 2. I want to write like this first. And that was also equal to UT plus half
AT square.
AT square we had. And this is also equal to VT minus half AT square we wrote. Then we wrote V square minus U square equals 2AS. And the last one is the S in the nth second. We wrote as U plus A into N minus half. This one we did not derive. But I'll repeat once again my conditions here. This is motion in a straight line and that too with a constant acceleration. All right. So, but yeah, this equation we derived from the definition of displacement equals average velocity into time. And we have told that only when the particle moves with a constant acceleration, the average velocity can be written as initial plus final by 2. Otherwise, we cannot write. By substituting U equals V equals U plus AT, we got this. Substituting U equals V minus AT, we got this. But we'll also show it from what? The graph. We'll also show it from the graph here. That is velocity time graph. You take velocity on x-axis, time on, velocity on y-axis, t on x-axis. Here velocity is a function of time. Velocity is the dependent variable, t is the independent variable. Time keeps on changing and the velocity keeps changing. Okay. Now, if the body is going, starting with initial velocity u and moving with an acceleration a, constant acceleration, the graph will be like this. It starts from here with an initial velocity u like this. Okay. Now, area under this and the time axis gives the displacement. The reason for that was talked already. That's what Galileo did in the beginning. What is the reason, children? I told you. Just listen here. I'll write separately somewhere here. Velocity and time. When I take that line, here velocity actually is changing, but we'll divide it into many small rectangles like this. So small that this variation is almost ignored. Actually, in the figure, I cannot make it smaller than that. If I make it smaller than that, you cannot even see the difference between the first line and the second line. But remember, this is infinitesimally small. You may call it ds. So small that you will think this to be almost a straight line. parallel to the time axis. So this area will be what? Simply this V and this small time dt, or probably V1 and dt. Like that, we'll write areas as V1 dt plus some V2 dt here, some V3 d3 dt, like that you get. This only is actually a method of integration. Try to understand. This ultimately will be some sigma V dt, children. So this will be nothing but the total area. But this V dt is nothing but what? Displacement. ds plus ds plus ds plus ds is delta s. All that if you do, it will be simply delta s. Are you listening to me? So finally, what we are trying to tell is that this area under this graph, the straight line and this time axis should be equal to the displacement. So that will be a triangle like this. Okay, and this will be a rectangle. So the rectangle area, you know very well, is what basically ut. This u is the breadth, t is the length. So this is ut, this area. And this area will be what? Half into triangle base time into this will be what? V minus u.
V minus u.
Basically, right? Huh?
Yes, sir.
What would be V minus U? You know, from the slope of thing, we know A equals V minus U by T minus 0 we wrote, right?
Yes.
Tan theta equals this by this we wrote. So V minus is nothing but 8. So 80 you write here. So the total, this total area, which is equal to displacement, which is what we call as S, is equal to what? Is equal to S, that is equal to ut plus half 80 square. This is how you derive it from what you call
equation.
the graph.
Yes, sir.
Okay, tell me. Sunday class people, not many people are happy, huh? But why? I don't know. All right, complete this. So any questions, Yogi and others?
No, sir.
No, sir.
I will be deriving them in the most general way a little later. But right now, let us understand it just that 10th class and 10th class way. In fact, now these relations are derived like this in 10th class without going for vector and integration approach. That is okay because the body is going in a straight line and with a constant acceleration. So even if you don't write the arrows like that, and even if you don't go for a more general method of doing it from integration, still that works. Okay.
Yes, sir.
Sir,
Yes.
then how do we derive Vt minus half At square?
Vt minus half At square from the graph.
Yes, sir.
You know, V is the final velocity. Huh?
Yes, sir.
So if you go to the top, V into T will give you this whole thing, right?
Yes, sir. Minus the other triangle.
This one. Huh?
Okay, sir.
This is whole Vt. If you
Minus
remove
the
this,
triangle.
this is equivalent to this plus this only, right?
Yes. Yes, sir.
Huh?
Yes, sir. Got it.
Do you understand that?
Yes, sir. Understand.
Everybody. She asked
Yes,
that.
sir,
That's a good question. Huh? Like if you complete it here, V into T will be total area like this, right? Huh? That minus this will be simply this, which was equal to this, and plus this. Isn't it so?
Yes, sir.
All right, good. Now, can I continue, children?
Yes, sir.
Right. Now that displacement covered during the nth second. Or straight line, I am saying distance also you can say if you want. Huh? So that will be in or during, that will be the correct word, during nth second. That means a particular second. Okay, that will be S nth equals S in n seconds and S in n minus 1 second. You call it as S in n seconds. This will be S in n minus 1 seconds. What is the idea, children? Say body is covering and body is moving in a straight line with a constant acceleration and traveled for 10 seconds, for example. This is 10 second ending. If I want to find out the distance during the 10th second, I should subtract distance covered in 9 seconds from the distance covered in 10 seconds. Then I'll get the distance covered during this 10th second. Isn't it so?
Yes.
Distance covered in 7 seconds minus distance covered in 6 seconds will be equal to the distance covered during 7th second. Distance covered in 11th second is distance covered in full 11 seconds minus distance covered in 10 seconds.
10 seconds.
So that's why we're writing like this. So it becomes what? It basically will be equals Sn, that is un plus half an square minus u into n minus 1 plus half into a into n minus 1 whole square. Isn't it? In t it is ut plus half at square. In full n seconds it is un plus half an square. So what do I get? Un plus half an square minus an minus a plus half a into
An minus
n square plus 1 minus 2n, like that. So it's only simplifying now. Un plus half an square. One more expansion is there, but if you understand it, you can straight away write it. Okay, I'll write an minus a plus half an square plus half a minus half 2 cancels an. So if you subtract and do that, what will go? An minus an plus an will go, right? Can you see here?
Yes.
Plus half an square minus half an square. This will go, this will go, this will go. Am I right?
Yes, sir.
Yes, sir.
This will go with this.
Even minus, yes, sir.
And this an will go with plus an, minus an plus an. And anything else will go? No. But this is half a minus a. So minus a by?
No, sir.
Half a will be there, no? Here. So what do I get now? Un minus a plus half a. Are we getting this or not? Tell me.
Sir, plus a
Plus a minus half
half
a.
a.
Something went wrong. Oh, here un minus a. This is not an. This is un minus u.
Yeah, yes, sir.
This is un minus u into n minus 1. This is not a.
UN gets cancelled.
Look at that. That is not a. Are you looking at it?
Yes, sir.
Yes, sir.
This is un minus u. All right. So un
Yes.
will go, right?
Yes.
Plus half an square minus half an square also will go.
Yes, sir.
Sir.
Yes, sir.
So plus u minus minus plus u
Minus half.
plus half a. Tell me.
Minus half.
Minus half a. So I'll write plus a into
Okay, yes.
n minus half. So this is the formula for this distance covered during n second. So with these 4 equations, you can do a lot of job in physics. I mean, this kinematics. Complete it. Aditya, Yogi Raghavendra, and then all those boys joined later.
Sir, join quickly, no, sir.
Payosni, why are you coming late? So u plus a into n minus half. This is the distance covered during n second. All right. Now, if you finished it, I'll show you how from simple 4 equations, motion in a straight line with a constant acceleration, we can really do some good problems, starting from the smallest level to the highest level we can take it.
Completed, sir.
Right. Now, let us see. Exercise and problems. Exercise and problems. Okay. Exercise will be simple. Problems will be difficult. That's why I all the time put exercise and problems. Exercise will be mostly, you will know what to do directly and you put a formula and get it. Problem means you have to think before setting it up. Okay. So I'll just give a name E or P. All right, E first. That means exercise, that is. It's going to be simple.
Okay, sir.
Right. A particle starts from rest and moves with a uniform acceleration along a straight line. Find the ratio of distances covered 1 during first, second, and third seconds of the motion. Two, in 1, 2, and 3 seconds from the start. So this is the first question, but under exercise I put. That means this question is not going to be tricky. This is a simple, straightforward question, so that you'll know that I should just see for what kind of a equation I can connect it up with. That's all. The regular method people tell, just see what are given, write them at one place, and then see the formula, connect it up. That's what you mean by exercise. Most of the times people confuse exercise with problems. Problem is, the word itself says it is a problem. Like, it's not going to be a straightforward thing. Exercise is, you know that steps already. You know the steps, so you'll repeat the steps. So that is exercise. Come on. So the solution would be what? The first one, during first, second, and third, the formula to be used is S during n second.
In seconds.
U plus A into
n
n minus half. So S in the first second. 0 plus A, we don't know. Leave it. 1 minus half. So how much is this? A by 2. S during second. That will be U is once again 0. A into 2 minus half. That will be what?
3a by 2.
2 to 4 minus 1. 3a by 2. S in third second. That will be 0 plus A into 3 minus half. 3 minus half is how much?
5a by 2.
5a by 2. Ratio is A by 2, 3a by 2, 5a by 2.
5a by 2.
So 1 is to 3 is to 5.
5.
Right?
Yes.
Proceed. Now, but what is the difference between the first and second question, children?
Sir, in the first question, it is during a particular time.
Particular
That
second.
is one. The first second.
That is just 1 second. That is,
Yes, and this is for the entire motion of the.
Yeah, that is in 1 second from the beginning, in 2 seconds from the beginning, in 3 seconds from the beginning. That is the idea. All right. Though it is exercise, and I told you conceptually they are good questions. In the sense, from the problem you can learn something about the uniformly accelerated motion. What is that something? We'll see. What is that something? Can you tell me now? That I'll come back later. Okay, let me finish up the question. After that, I'll come back. So what is the second one? Second one, how should I do that? S in 1 second. 0 plus A half A t square. This is right. This is A by 2. S in 2 seconds. That will be 0 plus half into A into 2 square. How much is this? 2A.
2a.
Yes.
S in 3 seconds. 0 plus half into A into 3 square.
9.
Right? This is 9A by 2. So the ratio will be A by 2, 2A is to 9A by 2. Will be how much, children?
1 is to
1,
4.
1 is to
4 is
4 is to 9.
To 4 is.
9. So that and this you look both. Now, something I would like to understand here. 2 points I should make. See, I said during, now one note I am putting here. If u is 0, two things are clear from this discussion with it. One is, of course, I've shown for first second, second second, third second. But if I do first 2 seconds and the next 2 seconds and the next 2 seconds, also if I take like this, like first second, second second, third second, we said the interval was 1 only, right?
Yes,
Now
sir.
here, first
Yes.
2 seconds, next 2 seconds, next 2 seconds, if I take also, the ratio of the distances will be 1:3:5:7:9:11, like that. I don't know whether you understood. Not 2 seconds, children, not even 3 seconds, 3 seconds, 3 seconds. If you want to check it, we'll check it. Yes, in the first 2 seconds will be what? 0, half a t square. How much? 4. How much is this? 2a.
2a.
S in 4 seconds, full 4 seconds if I do, that will be 0 plus half into a into 16. How much is this? 8a.
8a.
So this is in 4, this is in 2, right? So what is the distance during the next 2 seconds? 6a, right?
Yes.
Yes, sir.
Isn't it?
Yes, sir.
So 8a minus 2a will be 6a. This is the distance in the next 2. This is first 2, second 2 if I take, it will be 2a here and 6a here. Next 2 seconds you take, you will get, tell me, how much? How much did you get? 1:3:5.
10.
10a.
10a you get.
10.
If you want, you can check it. How? S in the next 6 seconds will be what? 0 plus half into a into 36. So this is 18a. So 18a minus 8a is what?
10a.
10.
10a.
So in the any time in the equal successive time intervals, equal
Successive
time
time.
intervals, the distance covered is in the ratio 1:3:5:7. What is this
Sir.
one? In equal successive time intervals. So this is the property of a uniformly accelerated motion. Like if you want to show that in the picture way, it will be like this. I told you yesterday also, but I'll show it again. Like if I take first 2 seconds, how much was that? 2a. This is 2a. In the next 2 more seconds, it will be how much, children? 6a.
See.
Total is 8a. Look at this. In the next 2 more seconds, it will be how much, children? Only here.
4.
This one from here to here.
88.
10.
10a,
10a.
sir.
10a, sir.
Yes, this is 10a.
Yes, sir.
From here. From total, of course, it is how much? 18a.
Yeah,
10, 6 plus 2. So 2a is 6a, 10a. What is the ratio? 1:3:5, like that. This is the way you will visualize the uniformly accelerated motion. I don't want you to mix up acceleration with velocity, velocity with force, force with what you call momentum. People mix up. They don't have any specific meaning for them. But remember, each quantity is its own physical quantity. Everything has a different meaning. It conveys something about the motion in a proper way. Do you follow this? So in a simple exercise also, there is physics to be learned, right? And then what else you learn other than this? What else you learn? This is during any 2 successive equal time intervals. This is right, but from the beginning, if you take in the successive times, what is successive times? In 1 second, in 2 seconds, in 3 seconds, if you take full times from the beginning, the ratio will be 1:4:9:16, like that. See, 1:4:9 is nothing but 1:3:5 if you do for every interval. 1, 4 minus 1, 9 minus 4, isn't it?
Yes, sir.
Do you follow my point here?
Yes, sir.
People are not responding.
Yes, sir.
Yes, sir.
Yes, sir.
So I want you to visualize this. What we're trying to tell is from here to here to A, from here to here, 6A. But if I compare like this one with this one from the beginning, once again, if I do like this, what is the ratio I'm getting? 2A is to 8A is to 18A, isn't it?
Yes, sir.
Tell me, that will be what? 1
Yes.
is to 4 is
4
to
is to 9.
9 is to 16, like that. This will be proportional to T square. So this kind of a what you call reading the maths, this kind of a connecting maths to the actual that space and time business is what you mean by understanding kinematics. Whatever mathematics comes there, that should be attached to what that space in terms of time. Space in terms of time, do you follow the meaning of it? How much space is covered in that particular time? So that is what you mean by visualizing, or that's what you mean by connecting maths to physics. All right.
Sir.
So the first exercise. Can I continue, children, now?
Yes, sir.
Yes, sir.
So I want you to understand some more physics from
Max.
the problems also, from the exercise also. Okay. Right. Now, second. A body is moving with a constant acceleration A. The constant acceleration A in a straight line what is the difference? What is the difference in the distances covered during any two successive seconds? Sachit Manga, are you there?
Yes, sir.
Okay. Just tell me the answer. Specifically, I would like to get it from you. Your body is moving with a constant acceleration A in a straight line. What is the difference in the distances covered during any two successive seconds? Come on. Others try. First try. Anyway, I'll do this here.
Sir.
Yes. Vaishnavi, Pavani, Shivani. Your voices all the time confuse me. Who is that?
Sir, Pavani, sir.
Pavani. Tell me, Pavani.
Sir, I got it as 3A.
3A. Let us see. How did you start, Pavani?
Sir,
It
first
is
I...
going in a straight line.
Yes, sir.
Let me just also try to drop some picture. Let me draw, because that's how you'll really understand physics problems, not otherwise.
Excuse me, sir.
Yeah.
I got A as the answer.
A is the answer.
Sir.
It says.
Yes, sir. Even I got it as A.
Yes, sir.
That's correct.
2A minus A, sir.
Manikarnika.
2A
Should I
minus A,
start
sir.
with 0 initial velocity, or I can still put U? I can put U, because I have not mentioned that it is in starting from rest. Huh? So any 2 successive seconds, let me say this is the nth second, this distance, and that next one is n plus 1th second, in that some distance. So what formula should I use?
F1 is equals to...
Yes, U into A into n plus 1 minus half is that one. S nth will be what? U plus A into
2 and minus 1 by 2.
by 2. So if I do n plus 1 minus Sn, you'll get A. So Sachit, tell me, what is your comment on this? This distance difference is coming as A.
Just the application of formula, right, sir?
Huh?
It's just the application of formula according to the question.
And formula is all right. Once again, I told you, in physics in general, but in particular in kinematics, can you reduce that to the space and time? That can you imagine that space in terms of time? Can you visualize that space in terms of time? That's what you mean by understanding. We have done it previously. In the previous problems you've shown, I told you already.
Yes.
So Sriya, you tell me.
Yes, sir.
See, the distance during any 2 seconds, 6 seconds, 7 seconds, 8 seconds, 9 seconds, the difference is coming to be A.
Sir,
See,
because it's
come on, this is distance or displacement, of course, in a straight line. It's going in the
Yes,
same
sir.
direction, it's not, doesn't matter. But that is coming out as acceleration. That's really something very special. That's it.
Yes, sir. Because it's constant acceleration.
Constant acceleration. Agreed.
sir.
Yes, Tanishka. You can take one example and check, no?
Sir, sir, any 2 successive seconds means, doesn't it mean 2 seconds, 4 seconds?
2 successive seconds. It will be not intervals of 2 seconds, 3 seconds like that. It is
consecutive.
It is not complicated. It is just one.
Sir.
Huh?
Consecutive.
Yes, consecutive seconds, not 1 second. Consecutive interval of 1 second each.
Okay, sir.
Sir, 2A minus A, sir.
2A minus?
A took, sir.
What is that you're saying?
Any value of A equal to 2A minus A, no?
2A minus A is A.
3A minus 2A, that's like...
Sir?
Yes.
Sir, is this just a result we found, or can we give any explanation for it, sir?
No, it's not giving explanation. It is trying to visualize it. It's trying. See, otherwise you say some formula, I put some got some A, I got A. No, my point is A is acceleration, Sriya. And this formula is the difference in the distances. So how different the distance became equal to A, should we not think?
Yes, sir, that's what I was asking. Like, is there an explanation for it, or is it just a coincidence, a result out of the calculation?
There's no explanation. There's an understanding of it. You understand? There's no explanation for it. There's nothing like any theory behind it. It's only
Okay,
trying to
sir.
visualize in terms of space and time.
Time.
Yeah, because look at this. To make it, even if you put u equals 0, it doesn't make a difference, right? Huh? So
Yes, sir. There
to
will
understand it, u equals 0, you think for a while. Huh? And acceleration value, you want to give some 2 meters per second. Per second is the meaning of acceleration. Do you understand? Actually, I don't want
Yes, sir.
people to say 2 meters per
Yes,
second
sir.
square, because second square has no meaning. 2 meters per second means what? For every 1 second, say if it is first second, if I take 0 to 2 meters per second, the velocity changes, right? And in one more second, this is 1 second, this is another 1 second interval. It will change by 2 meters per second more. So that will become the velocity part. This one is not acceleration I'm showing. Do you follow my point? The speed is changing for every second by 2 meters per second. The speed is changing. Huh?
Got it visually, sir.
What is it? What is it? Tell me.
If an object moves in a straight line,
Yeah.
as we are considering in straight line for
Yeah.
now, it is traveling with given u meters per second and constant acceleration of a meter per second.
Yeah.
It means for every unit second, it is changing a meter per second.
The speed. Yeah, the speed is changing.
In the
The
velocity.
speed or velocity is changing.
Yes.
A meters per second.
Per second.
Yeah. Yeah. For every second, the velocity changes by a meters per second.
Yes. Yes. That change is called acceleration.
That's correct. But the thing is, the difference in the distances. See, distances is coming here. Velocity you're talking. What Sachit says is correct. What he says is, in every 1 second, the speed is changing by a meter per second. For every second, the speed is changing by a meters per second. So how do you connect the distance here with this? See, this is a meter per second. Do you understand?
Yes, sir.
A meter per second means the speed itself is what? It is the distance covered in 1 second.
1 second. Yes.
Isn't it so? So
yes, sir.
So the difference has to be equal to what? A meters.
A meters.
You can put some numbers and also check it. So this is what I focus upon. Try to understand. Formulas help you in doing exercise, but formulas do not help you in doing problems.
Yes,
formula's meaning will help you in doing a problem. Okay. All right.
Yes, sir.
Just now I'll show one problem. So today Sachit Manga is there. I want to just see how he is going to do that. All right. Sriya, I'll give a problem which you might have done with me already. Yeah, Raviteja, tell me.
So this is only for successive intervals.
Yeah. Isn't it so? Isn't it so?
Yes, sir, it is.
You should say now, not me, Bhuwana.
Yes, sir, it is only for success.
Yeah.
Consecutive success.
Consecutive success doesn't matter. Okay. One more question here. Can I go to the next problem I'll give you now?
Sir.
I'll say this is a problem. It's a very, very good problem I like. I can give you directly, but I would like to read from the book straight away, so that you don't blame me that I'm hiding any information or the wording is given in such a way that you don't get the question, all that. I'll simply give it from the question, from the book. Come on. At a distance, same question I'll give you. Sri, if you remember, those people who did it with me already, Just
Yes, sir.
do it. Don't blurt out the answer. I don't know. If you remember, that's great. If you did not remember, that's bad. But let me see. At a distance L equals 400 meters from the traffic light, brakes are applied. Brakes are applied to a locomotive. Moving at a velocity v equals 54 kilometer per hour. Determine the position of the locomotive. Relative to the traffic lights. Traffic light 1 minute after the application of brakes, if its acceleration is a equals minus 0.3 meters per second square. So be careful and remember, just based on 1 or 2 equations we've written down there.
Yes, sir.
So Bhuvana, were you there when I did kinematics?
Yes, sir. I was here.
You are there. Okay. Tulasi Vardhan, I'll give you freedom to tell me what you've done. Tulasi Vardhan, Vamshi, are you there today? I do not know. Tell me. But remember, I'm just asking you to get into the problem solving mode. What are the equations to be applied? Only these. S equals ut plus half at square. Of course, remember 3 different forms of it. U plus v by 2 into t, or vt minus half at square. Anything like that you can apply. This one, or v equals u plus at, or v square minus u square equals to as, or snth equals u plus a into n minus half. Just based on these 4 equations, we are going to do wonders. So for that reason, I just, without going for generalization like integration, all that, I want you to push into that kind of problem solving first to begin with. So tell me.
Sir, I used u plus half it square, sir.
All right. What answer did you get?
I got 800.3. I got, sir.
What?
800.3.
No, just a minute.
Sir, maybe I didn't calculation mistake, sir.
Mute your audio. I'm hearing voices from the room.
Sorry, sir. Sorry, sir.
Mute it. Come on. Vamshi, Tulasivardhan. I'm waiting for you. Aditya. Okay. Sriya?
Yes, sir.
What shall we do?
Draw a diagram.
Draw a diagram for this, not much, but anyway.
Okay.
Sir, I got the answer.
Tell me, Sachit.
Sir, 40 meters.
40 meters. Reasonably so, to begin with. So tell me, Sriya, is this correct?
Sir, I didn't completely solve it yet.
Okay. Bhuvana? Okay. Correct only. Huh? All right, let me see. Sachit, tell me, what did you do? I'll write your solution here.
Sir, I took the equation s is equal to ut plus half at square.
S equals ut plus half at square has taken. So S equals U is 54 km per hour means how much?
15 meters per second.
15 meters per second.
5 into 5 by 18. Huh?
Yes, sir.
54 into 5 by 18 is 15 meters per second you get. So 15 meters per second into 1 minute.
60 seconds.
60 seconds plus half into
Half
minus 0.3 into t square. 60 square.
3,600.
3,600. So this will be 900 minus,
yes, 900
minus 0.3. How much is this? 18. 540 or what? This is 1800.
540, sir.
540. Sir. So this will be how much?
360.
360.
Yes,
So
sir.
this was the traffic signal, right? So initially the car was, automobile was here at 400. So this stopped after 360 is
meter.
what Sachit Manga says. So the answer should be 40. Is this correct? No.
We got it as 25 meters from this traffic
Yes,
signal.
sir.
Let us check it. Huh?
25 meters from the
Let me check it. Initial velocity is so much, children, 54. Huh?
Yes,
I would like
sir.
to know in how much time it stops actually. So I'll use V equals U plus 80. When it stops, huh?
Yes, sir.
15
50 seconds, sir.
It's 50 seconds, sir.
Yes, sir, in 50
0
seconds.
equals U.
15 minus into T. So T will get it as 50 seconds.
So in 50 seconds only it is stopping. So if I write S equals ut plus half at square again, I'll get S equals 375. I'll get, check it.
Meters.
So the
Yes,
answer
sir.
is 25 meters I'll get. So
Yes, sir.
which is the right one, you argue for your case. So this is what why am I calling it a problem? It's not a straightforward question. It's not a straightforward question of only putting an equation. So I'll show you some tens of problems like this. The first time you'll always go wrong. That's what you mean by a problem. It's not going to yield to regular run-of-the-mill kind of an approach. So Sachit, tell me. Or if you want to say your answer is correct, argue for it.
I agree to your answer.
My answer only you'll agree. Why? Actually, someone in the second years was asking, sir, you're teaching theory when like whether sir does problems. Believe me, if I give you problems out of 100, you may not get even 10, because my understanding of problems is different from your understanding. Probably most of the times people confuse problems with exercise. Problem is a problem, right? I have a problem with my friend. I have a problem with my father. I have to solve for it. I have to solve my problem with my father because all the time I'm studying, but he's still shouting at me. So that's a problem, right? So problem is all the time somewhat
Problem.
it's not straightforward thing. Problem of poverty of people, problem of floods, right? So they require some good solution, right? But come on, I don't want you to accept anything just for the sake of it. So what was the mistake in doing this way, Sachit?
I took the time as the 1 minute interval in which the brakes are being applied.
Yeah, actually the problem is very, very cleverly framed, child. He did not give 10 minutes, he gave 1 minute.
Yes.
Try to understand. Otherwise, people argue for it. 2 minutes means what will happen? See, he applied the brakes. The acceleration decide the time in which it stops. And we saw that 50 seconds only it's stopping. So in 10 more seconds, nothing is going to happen, right? Isn't
Yes,
it?
sir.
So,
Yes.
so that's why you should say the answer is 25, not
40. Okay.
isn't it so?
Yes, sir.
So this kind of problems will be many. So I want you to be attentive, very, very attentive.
In this problem, they misstated us with that 1 minute.
Yes, that's the whole idea. They want to do that because otherwise this is not a problem only, right? Huh?
Yes.
Yes, sir.
Right. So I'll be bringing some very, very good problems tomorrow. Only
Okay,
based on
sir.
these 4 equations, not anything else.
Yes, sir.
So let us once again meet tomorrow at 7:30. All right.
Okay,
Okay, sir. Thank you,
Right now
sir.
I'll be closing it.
Thank you, sir.
End the show.
Thank you, sir.
And then stop share.
Thank you, sir.
Stop share and then end the session.